Alright, guys. So, in this video, we are going to take a look at some of the most common, most popular fundamental quantities and the units. Derived, I beg your pardon, derived quantities and units. We did fundamental in the previous video. So, in this video, we are focusing on derived quantities and the units. So, we're going to take a look at a list of the most common, most popular. So put out the quantity, then I'll give it the derivation. And mind you, the derivation is the exact thing as the formula. So when we say derivation, we mean the formula. So we'll begin with a very basic one right now, and that is area. Alright, area, the formula for area or the derivation for area. So you can use both words interchangeably. You can either say the formula or you can say the derivation. But since most people are more familiar with formula, I will stick to formula. So the formula for area is length times breadth. That's the formula for area, length times breadth. And we're also going to be taking a look at the units. So not just the formula, but the units. So area has a unit of meter square, meter square. So it means that when you're solving for area, be it in mathematics or in physics, your unit should always be left in meter square. And as a matter of fact, this applies to every other quantity. Whatever you're solving for, make sure that you add the unit at the end of your answer. So that will be very important, because if you don't add units, it will reduce your marks in whatever exam you're writing. Now, the next we'll be looking at right now is volume. And the formula for volume is length times breadth times height. The unit for volume is meter cubed. So it means that if you solve for volume, your unit should be left in meter cubed. Alright, next up really quick is speed. Alright, yeah, speed. The formula for speed is distance all over time. As the formula for speed, distance all over time, and the unit for speed is meter per second. So you can write it like this, or you can write it like this. That is because this SCC carries an invisible one. And when this invisible one comes to the numerator, it turns from positive to negative. Alright, so that's by the way. Then the next way we're looking at right now is something very akin to speed, and that is velocity. The formula for velocity is displacement over time. Now you see why I say they are very, very akin. That is because the way we represent them is exactly the same, but the names are different. Why speed is distance over time, velocity is displacement over time. You understand? One of them is a scalar quantity, while the other is a vector quantity. So that is the discrepancy between both of them. And as regards to units, they share the same unit. That is meter per second, or you can write it like this, meter per second. Now the next we'll look at right now is acceleration. Alright, the formula for acceleration is simply change in velocity all over time. And as a matter of fact, whenever you see this symbol, it means change. It can be changed in anything. In this case, change in velocity. Alright, and the unit for acceleration is meter per second squared. Or it can be written like this, meter per second squared, because this is a 2. When this 2 comes up on the numerator, it turns from positive to negative. and that is what we have here. All right, next we'll look at right now is force. The formula for force is mass times acceleration. It's very, very popular. Now, the unit for force is Newton. Newton is the most common unit for force, and the symbol is capital letter N. Now, the next we'll look at right now is weight. Weight. Weight is akin to force in terms of units, but in terms of formula, there's a slight difference. Weight is also mass times acceleration. Yes, they are the same in terms of representation, but force rather is just mass times acceleration. But as for weight, it is mass times acceleration due to gravity. So they're very, very similar. And as for the unit, it's the same thing, no difference, Newton. Do not confuse weight for mass. Mass is different. Mass is not a derived quantity. Mass is a fundamental quantity. You know, we talked about them. The three most common fundamental quantity, remember, are length, mass, and time. Unit for mass is grams or kilograms, and the unit for weight is Newton. So do not confuse both units for the other, right? Yeah, that's it. The next one we'll look at right now is what I call pressure. The formula for pressure is force over area. Force over area. So it means if you're solving for pressure, that is a formula you should use. And the unit for pressure, well, pressure has several units. All right. So one of the units for pressure is the Pascal. Pascal. Another unit for pressure is Newton per meter squared. Do you know how we got this? You know how we got this? That is because this Newton you see is for force, and this meter square you see here is for area. Now, since we have force over area, this is Newton per meter square. Remember, this can be written as this, Newton over meter square. This 2 comes up, turns to minus 2. Now, so it means this Newton you see here is for force, and this meter square you see here is for area. I hope that's clear. Now, other unit for force, or pressure rather, that we're going to look at right now is millimeter mercury. You use this when you're solving questions in Boyle's law in chemistry, Boyle's law, gas law, those general gas law questions. I would say you will need this the most. So these are the 3 most common unit for pressure. Though we still have one, that is the atmosphere, ATM. Alright, so you use millimeter mercury and atmosphere mainly when you're solving questions on gas laws. Now, the next unit we're going to look, quantity rather, we're going to look at right now is energy. Energy. Energy or work. Energy or work. Both of them have the same formula, and the formula for both of them is force times distance. You see? So you can write it like this, F times S, that is because S can be used to represent distance, or you can say F times D. The choice is yours. But most commonly, force times distance, F times S, is the one that is used in most physics calculations. And the unit for energy or work is joules. Joules is the most common unit for energy. Joules. Alright, or we can write it as Newton per meter. Newton meter rather, not Newton per meter. I believe you know how we got Newton meter. Newton here is for force and meter is for distance. So it is Newton times meter. But most commonly when you're solving, leave your answer in joules. That is because joules is the more common unit for energy and work than Newton meter. Alright, so the eventual quantity we'll talk about in this video is power. Power has a formula of work all over time. So that's the formula for power. And the most common unit for power is watts, right? But we can coin other unit for power, which is Newton per Newton meter. All right. Sorry about that. I mean joules per second, or joules per second. Now look at this. Joules you see here is for work or work done. Then this S you see here, which is the seconds, is for time. So when you say work over time, you simply mean joules per second. So it's the exact thing here. So logically, you can get the unit from the formula, all right, but it doesn't work in all cases. But in most cases, it does work. So you can either leave your answer in watts, like you can see here, right? Or you can leave your answer in joules per second. Most commonly, you should leave your answer in watts. Alright, so that's it for this video. I believe you learned something today. And do not forget to share this video with your friend who may find it helpful as well. And like the video, leave a comment below. And if you're yet to subscribe, please support the channel by subscribing. Thanks for watching.